Welcome to the deep dive. Today, we're going to be getting into hydrogels, specifically how they're changing the game in agriculture. We'll be looking at a research article called Recent Advances of Hydrogel in Agriculture Synthesis, Mechanism, Properties, and Applications. It's dense, but we'll break it down. Ready to see how these things work?
Absolutely. It's a field with huge potential, tackling things like food security and water scarcity.
Right, those are huge issues. It's easy to forget how precious water is, especially when you consider what I was blown away by this 88% of all the fresh water we use globally. It's for irrigation.
It's a staggering figure, and it really highlights the need for solutions like, these hydrogels. That could be a game changer.
So like super sponges for water, right? That's the basic idea.
Well, that's a good place to start, I guess. But hydrogels are far more complex than your average kitchen sponge, of course. They're actually intricate 3D networks of polymers, able to absorb and hold incredible amounts of water. And the best part, they don't dissolve. Like tiny reservoirs right there in the soil, ready to supply the plants when they need it most.
Okay, so that's pretty cool. But polymers, networks. I'm no chemist. Can you break that down a bit more?
Sure. Think of a polymer like a long chain of molecules, like beads strung together. Now, picture those chains linking up to each other, creating this complex three-dimensional structure. That's your polymer network. And it's actually how those chains link up, a process we call cross-linking, that really dictates the properties of the hydrogel. Like, say, choosing different types of flour and baking methods. It's going to change the texture and density of your cake. Same idea here.
So the ingredients we use and how we bake them determines what the hydrogel can do.
Yes. You see, we can use natural polymers, say, like proteins found in plants as our starting point, right? Then we introduce synthetic polymers like polyacrylamide, known for its incredible water absorption abilities. It's about combining the best of both worlds.
And then we sprinkle in some nanomaterials for extra superpowers, right?
You got it. These tiny, tiny particles can be added to further fine-tune the hydrogel's properties. Like, say, adding nanomaterials that enhance conductivity. You're basically turning that hydrogel into a sensor.
Now that is what I'm talking about. But this cross-linking, how does that even work?
It's all about chemistry.
Yeah.
We're talking about creating chemical bonds between those polymer chains. There are different methods, each with its own pros and cons. Hydrogen bonding, for example, that creates temporary bonds, which results in a more adaptable hydrogel, so it can adjust its structure in response to changes in its environment. Pretty cool, right?
So not just soaking up water, but actually responding to what's going on around it.
Exactly. Take tomato growth, for example. Studies have shown that in drought conditions, using these hydrogels can actually increase tomato yield by 20% compared to conventional methods. That's a big deal in a world facing increasing water scarcity.
Wow, 20%, that's huge. So these hydrogels aren't just conserving water, they're actually helping plants thrive in tough conditions.
Right. And it's not just about the water retention either. They also improve the soil structure. Makes it easier for those roots to grow and access nutrients. Healthy soil means healthier plants, which ultimately means a more secure and sustainable food supply.
This is fascinating. So we're conserving water, boosting plant health, and you even mentioned that hydrogels can release fertilizers slowly over time.
Yeah, that's where things get even more interesting.
Yeah.
Especially when you consider the efficiency and environmental impact. But let's dive deeper into that aspect after a short break. When we talk about hydrogels releasing those fertilizers slowly,
Right.
it's not just about cost saving for farmers or even reducing water use. It's about the environmental impact.
Right, because if those nutrients aren't used by the plants, they can end up in our water, right?
Exactly.
Yeah.
But with hydrogels, we can encapsulate the fertilizers, control how they're released,
Okay.
make the whole process more targeted, eco-friendly.
So it's like, what, a smart delivery system right there at the roots?
Exactly. And this idea, this controlled release, it's not just for fertilizers.
Oh.
We can do the same thing with pesticides.
Right.
Instead of those widespread sprays, imagine releasing pesticides only when and where they're needed, triggered by specific things in the environment.
Okay, now that sounds like something straight out of a movie. How's that even possible?
Let me give you an example. Researchers have actually developed a hydrogel that responds to pH changes in the soil. So certain plant diseases, they can cause the soil to become more acidic.
Okay.
This hydrogel, it detects that change, that shift in pH, and it releases the pesticide right when and where the disease is most likely to hit.
That's amazing. Precision agriculture at its finest. And it's not just about efficiency, it's about minimizing that environmental impact.
Exactly. And that actually leads us to another really interesting application of hydrogels, soilless cultivation.
Ah, yes. You mentioned that earlier. So essentially growing plants without using soil, right? Kind of like, I don't know, those futuristic hydroponic farms.
Precisely. And while those traditional systems, they often rely on substrates like, perlite or vermiculite,
Sure.
hydrogels, they offer some real advantages.
Oh, in what way?
Well, think about some of the challenges with those traditional substrates.
Okay.
They can be messy, prone to, powdering, and they don't always retain water or nutrients consistently. But hydrogels, we can actually engineer them,
Interesting.
create that ideal growing environment, fine-tune their properties, get that perfect balance of water retention, aeration, nutrient availability,
Okay.
all within what is essentially a stable and manageable medium.
So it's like designing a custom soil tailored to each plant's needs.
Exactly. And that level of control, it's really crucial, especially when you're trying to maximize yields in, say, vertical farms or greenhouses.
That makes a lot of sense. So we've got hydrogels conserving water, improving soil health, releasing fertilizers and pesticides with, pinpoint accuracy, and even allowing us to grow crops without soil. Is there anything these things can't do?
Well, they can also help clean up polluted soil. You see, heavy metal contamination,
Right.
it's a big problem, affects plant and human health.
Yeah, for sure.
Hydrogels can actually remove those harmful metals from the environment.
Really? Wow. How do they do that? Do they absorb the heavy metals somehow?
Chemistry. It's all about the chemistry. Remember how we talked about customizing hydrogels, adding specific functional groups?
Right, like adding ingredients to a recipe.
Those functional groups, they act like, claws, grabbing onto those specific metal ions, holding them tight. So imagine introducing these hydrogels into contaminated soil.
Okay.
They bind to the heavy metals, effectively remove them from the ecosystem.
That's incredible. A detox treatment for the soil.
And the best part, researchers are already developing biodegradable versions of these heavy metal-absorbing hydrogels.
Wow.
That way they don't become pollutants themselves.
That's fantastic.
Yeah.
So we're talking about a truly sustainable way to clean up contaminated land. This is amazing. This deep dive has really opened my eyes to what's possible with this technology, but I have to ask, what's next? Are we just scratching the surface here with hydrogels?
Oh, absolutely. We're on the cusp of even more amazing advancements, especially in the world of smart agriculture.
Smart agriculture.
Yeah.
Okay, what does that even mean?
Well, smart agriculture, it's kind of about, imagine a field where each plant has its own little sensor, constantly monitoring how it's doing, sending that data back to the farmer.
So we're talking next level precision agriculture here. What kind of information are we talking about?
Moisture levels right there at the roots, nutrient availability, even early warning signs of disease.
Oh, wow.
And this real-time data, it means farmers can make really informed decisions about, irrigation, fertilizers, pest control.
So we're talking less waste, better yields, healthier environment, all thanks to these sensors.
Yeah, it's about optimizing everything.
Okay, that all sounds incredible, but those sensors, they need power, right? We can't be running wires through entire fields.
Right, and that's where things get really interesting. Researchers are looking at ways to actually put supercapacitors, those energy storing devices, directly into the hydrogels themselves.
Hold on, so the hydrogels could be, powering the sensors themselves?
You got it, self-powered sensors.
Wow, no batteries, no external wiring needed. It's like we're embedding intelligence right there in the soil.
It's a pretty elegant solution, and it just goes to show how much potential these hydrogels have.
Yeah.
And remember, we're already developing those biodegradable versions.
Right.
So it's about the future, but a sustainable one.
It's amazing. It really feels like we're on the brink of a whole new era in agriculture, and it's all thanks to these hydrogels. From those tiny structures, the controlled release, to now self-powered sensors. This deep dive has been honestly mind-blowing.
It really speaks to the power of science, right? And what happens when we push the boundary? Look at those everyday materials in a new light.
Absolutely. Who knew something as simple as a gel could hold the key to, maybe even solving some of our biggest challenges? It makes you wonder what other discoveries are out there just waiting for someone to explore them. And on that note, we'll wrap up this deep dive into the incredible world of hydrogels. Thank you for joining us. Until next time.